All right, so we'll continue with the chapter 4 of paper 1 AS computer science, and we have done different addressing modes. We have done direct, indirect, relative, and immediate. But there was one addressing mode that still remained. That was the offset addressing. So today, in this particular question, we will not only going to learn about the tracing, but we will also going to learn how the relative addressing can work and what this offset thing is. So let's have a look on this question. The question is given to us. Now, there is one thing that is missing. If you look into any previous question, if you go back and have a look on any previous question, it's a similar question, you will always going to find out the addresses. For example, the instruction LDD 800 is on address 100. And then you have another instruction add 801 on address 101. Addresses are given. But if you look and come back here in this question, addresses are not given. So what you have to do, you have to write down the addresses by yourself. This is the very first thing that you are going to do. If you have a question which has an offset, okay, and addresses of the instructions are not given, and it's also been not mentioned that from where the addresses are beginning, then what you're going to do, you'll start your addresses from 0. So this is the strategy number 1. This is the step number 1, solving such questions that have the offset mentioned in them. Okay, so 0, 1, 2, 3, 4, 5, 6. Definitely you have to do this in your paper, in your exam sheet. 9, 10, 11, 12, 13, and 14. There you go. So now you have your addresses of each and every instruction. Another thing that you can see here is the labels. Instead of the addresses, they have given us the labels. This is just like you name your variables. Okay, so start prog, it's a label, end prog, offset, and value. These are the labels. So these are the two new things. You have to mention the addresses by yourself. You have to know the labels, how they work. Let's begin solving this question now. Let's start with the instruction at address 0. LDV is for relative addressing. LDV hash offset. Basically, offset often means that you add the given offset. Offset is, you can imagine it just like an index register. Some value in offset can be given. Okay, and you have a command something like this. Okay, and you just maybe just offset, yeah. And the offset value is always added into the base address from where you're running the instruction. Okay, here right now the base address is 0. So if you add any value into 0, it still remains the same. So that is relative addressing. But right now, just try to focus on what they're offering us here. Okay, this particular question. So LDV hash offset. Now where this offset thing is, there it is. All right. So inside the offset, it's 10. So LDV hash offset mean whatever is at the position 10, you have to fetch it into accumulator. I'm just repeating myself. It's mean that whatever is at the position, the location 10, you have to fetch it into accumulator because inside the offset, it's 10, base address is already 0. Okay. So at the position 10, at the location 10, you can see that the contents are 50. So LDV hash offset means LDV 10, and at 10, the value 50 is placed that is fetched into the accumulator. They have already, partially solved this question for us, so we can see and understand. Okay, so 50 is fetched, running this instruction into the accumulator. We move to the next step. We are comparing the accumulator value with the label value. What is inside value? It is 32. So whatever is in accumulator register, it will be compared with the value 32. So compare value means compare 50 with 32. So we're comparing 50 with 32. It will not be compared because if it would be compared, it has returned us true. But right now, comparing this value is returning us false. So if it would be true, we then would have executed JPE. But right now it's returning us false and there is no JPN. So we'll skip this JPE part and continue from here. JPE would have been only executed if the compare instruction could have returned us true. Okay, so we're just moving towards next line. Out CH. Out CH means that whatever is inside the accumulator register, just display the character of it. Inside the accumulator register is 50. The respective ASCII value is 2. So 2 is shown here. Okay, let's move on. People, you're getting this? We're all good? Okay, we have executed 2 instruction. Let's move toward the 3rd instruction. That's great. That's great, Anand. Rest of the team, they're doing good. We have more people joining us in. We have Ubaid, we have Abdul Hadi, Ryan, we have Umar Beg, and Unab as well. Okay, so first 2 instructions has been executed. We are moving toward the 3rd instruction. That is that actually is skipped because compare value returned as false. So we executed the 4th instruction. Okay, this is 4th because 0, 1, 2, 3. And let's move towards the next instruction, that is LDD offset. Whatever is in offset, loaded into accumulator. Inside the offset, it's 10. So 10 will be loaded in now accumulator. So they have solved this question for us up to this level. It's been loaded, okay? LDD offset. Then increment, it will be incremented to 11. INC increment means whatever inside the accumulator, just add +1 to it. Okay, so incremented. Then after incrementing it, stored back into the offset. So this 11 is then again placed back into the offset register. Okay, so it's mean that offset is now updated to 11. After doing this, storing the value to the offset, jump to start prog. So we're jumping back to start prog, and we are going to do the same process again. So we're just doing this in a loop. LDD hash offset. Now inside offset, it's 11. So we're going to fetch the value from the location 11. That is 65. So this 65 will be loaded in accumulator register. This value will be compared with the value inside value. It's 32. So 32 and 65 does not compare. We'll skip the JPE and we'll out character. Whatever the values inside accumulator, this is 65. So find out what is the character for 65. It's capital A. Capital A will be displayed. There we go. Okay. Out character, again load offset. Inside the offset, now it's 11. Now it's 11. So 11 will be fetched. And guess what? They'll increment it. After incrementing it, it will become 12. And after incrementing it, they're going to store it back to the accumulator register like this, 12. All right. And they're going to jump back to the start prog. So jumping back to start prog and doing the whole thing again. I guess you got the idea. Almost you got the idea, because as soon as you're going to fetch 32, all right, it will compare. And 32 will be compared with the 32, and you will jump JPE to end prog, and you're going to end the program. So this is all it's about. But let's just do this quickly now, because we have the idea. The next number, because now if you're doing LDV offset, Inside offset, it's 12 and 89 will be fetched. It will be compared. Okay, compare nahi hoga. So 89 means y. Y will be displayed. And after doing this, increment. Before incrementing, sorry, we will going to load offset. Well, load of offset, it will become 12. Incrementing it, it will become 13, and we're going to store it back to the offset, and we'll jump back to the start prod. अब क्या होगा? Offset 13 LDV 13 को fetch करेंगे. We're going to fetch 13. 32 will be fetched. It will be compared with the value. Inside the value is 32. We're going to run the JP instruction for the first time. And we go to the end prog and we end. So guys, this will be the trace table values for your full marks. We have just learned about how the LDV thing works. We have learned about if the values are not given, we have to give down all the addresses of all the instruction. We will start from 0 if they will not ask us to. For example, I guess there is one question here in the past paper in which they have set the base value to 100. Then you have to start from 100, 101, 102, and so on. Right? So that's the case. Yes, Nab, it's definitely getting recorded. I'm just switching off the record so I can hear to your questions.